And welcome back to Career Build Series. This is episode 135. So we're starting off where we left off with the CB. I think I have a name. I'll probably call it Seagull, I think. But we're back here. Just added the fat hips on there. Did a little bit of balancing. Let's get right in here on the door. So I want a door on one side. I don't know if I'm gonna be able to do this with a custom door. We will see. I might actually be able to fatten that up like that. Let me see. Okay, so let's start putting parts in. I want a custom sealing door. I need that volume to seal. And I kind of want a window. So let's try door parts and see if I can put a custom door in. I may or may not. So we want door frame corners here. There's a reasonable chance the answer is no, and I don't have enough space. I need to be able to get a person in. I need to be able to drag the bodies of my unwitting victims slash rescue people in there. And so I need to be able to have enough space here. And so let's see if I can do it. This might be too tight. And it's starting to look like it's too tight. Yeah, I can't foresee this working because I need a hinge in there. That's fine. It's just too tight. Yeah, see, there's no way. Okay, perfect. So as much as that would have been nice to have, let's see if I can get a hatch. I should be able to get a hatch in there. I want a manual sliding hatch. Okay, that will fit. Yeah, so that will fit definitely. And then I'll test out, see how this works with actually getting my ass in there. So the gear come up to an intermediary position. Let me see where I have a gear controller here. Let me see where they should be. Gear is set to 0.5 -1. So let's update this. Here, actually, 5 on the seat. Okay, let's update this micro to spawn this. Let me check the door. I need to be able to make sure I can get in and out of the door. So, all right, so we're in here. Let's put the gear. So the gear is currently in its down position. In its up position, it actually rides up high out of the water. So we need to be able to make sure we can get in there with the gear there. I can actually probably go higher on that gear. Let's do that to start with to cut some of our problems down. And so let's make this point 7.5. Let's spawn that, see if I can get inside. All right, so let's go in. Let's raise the gear. So the gear start in the down position just so that I can spawn it in a hangar. It is amphibious. All right, so we would crawl here. This looks like this will work fine. I just need to put a step there. Oh, look at that, right in. It's a little bit weird, but I'm going to put a staircase there. It'll be able to get in there. All right, so that's pretty good. That actually works pretty. Staircase is going to suck. It really will. It's not terrible. It's not going to be the best putting a staircase in here, or ladder pieces rather. Just because you need 3 blocks of space, like you see. This is as close as I can get to there, so I lose a little bit of space inside, but it's not the end of the world. It's really not. Okay, and then I'm not doing 100 of these staircases. I'm gonna kind of may do this instead. We'll expedite this process here. All right. There we go. All right, so we have a little staircase in there. What is this here? That can go away. Beautiful. That needs to stay there. It's fine. All right, so we're making good progress here. Can actually have to be careful. Symmetry. So that's good. Still plenty of space for seating. We can do a row of seats there. We can do a row, do some seating back there. Plenty of space for seating. I'm not concerned with that at the moment. Symmetry, please. Thank you. All right, and we'll do symmetry off again. So that can't go there with that wheel there. That probably can't go there with that wheel there. Can we do a straight cutout here? We might be able to. Just want a kind of a little ledge that I can have my guy stand on here. Oh, get out of there. I didn't click on you. Despite me probably actually clicking on you, I didn't click on you. Okay. Alright, so that just gives me kind of like a little ledge to stand on here, and I want to put a stair there, but that wheel's going to interact. Like, I want to put a ladder section right here. Like, that's what I want to do, but as you can see, it interacts. And then, like, if I don't have two ladder pieces, it's pointless having ladder pieces. Let me see if I can get it in there. I doubt it. I need 3. I know I need 3, so yeah, see? Interacts with the wheel. That's fine. I'll go like that instead. Just a little notch out there. What is this? Door. How tall is the door? I think it's 7. That is dangerously close to working. But I have to worry about the water line. So let's drop this in the water. Yeah, that wouldn't work with the water. So let me see if I can get in and out of this a little bit easier. Yeah, see, like now I can come here and I can kind of climb up. And then, see, that's actually hard to get into. So I think I'm going to get rid of that. The slope, it allowed me to climb up on the slope and I can get in. As long as I can get in on the slope, that's fine. And actually, I like the look of it better, so yeah, let's stick with what works. Okay. Wow, I can hit every button but the one I want. There we go. All right, so let's try this now. We want to go in and out. We know the wheels are fine where they are. Let's go ahead and open this up. We don't get flooding. That's the main issue here. Is we want that high enough we don't get flooding. We can climb up here, crouch, and right out. All right, beautiful. That works well. So there's my little entry door. All right. Fits, looks good. It's not a pain in the ass. Across from this, I want a window. Okay. A porthole, I think. Yeah. And I can't do a porthole there because of that, but there. Yeah. Yeah. Okay. Oh, that's ugly. I didn't think of that. There we go. That's kind of cool there. Don't get much window on this side. I could. Yeah, that I need that block there. All right, I was gonna put a little window there, but I think we could do without a window. Yeah, we. Might redo how I do this window. What's that? I don't think it's a 1x2 angle though. Yeah, I forget what the angle is on these windows. I think they're 45s. Again, more window blocks, please. Thank you. Yeah, it's 45s. Okay, that's fine. Alrighty. Actually might integrate further back, square this out a little bit. I think that's what I'm going to actually do. Yeah. Let's try that for now. So that's good. Hatch in, window in. Starting to make some progress on this here, getting it functional. Floats nicely now. We have most of the engine components in, so we know that weight's not getting added. We have the fuel set to 20%, which I'm actually going to go back in. I want to read. I want to get a gallon reading on this here just to check our fuel capacity, which is looking pretty promising. It's floating beautifully. Look at that. It floats really nicely. Where are you at? Fluid meter. So that is 366 liters. Let me do my liters to gallons. So that's what 6, 7, 20, 32, 732, 732, 193 gallons. Beautiful. So that has about almost double the fuel capacity of Katydid. And it should be more fuel efficient than Katydid. If you think about it, Katydid has to move a rotor, a tail rotor, and a prop. This has to move a prop. All of its lift is created by its forward momentum. So that is good. I'm just kind of seeing how it's floating here. All right, so we are in business here. This is really coming along well. I'm trying to think what I want. I want this up in the air. I want everybody to see this in the air. So I need a microcontroller for the engine. That's something that's important. So let's get that rolling here. Yep, I think that's what I should do next. So let's get a blank microcontroller. Single engine, isn't this? This is a single engine. Trying to think. Do I have a microcontroller? Yeah. Let's do this. Okay, let me go ahead and save this here as CB backup. Let's open up. Where's my airplane basics tutorial? There it is. Let's see if this will give me any sort of advantage on time, because I don't want to waste a ton of time rebuilding something I've built 1,000 times. So let's get this engine here. All right. And let me just kind of interrogate this and see what we're at here. All right, stoichiometry setup. What is this? This is starter is good. What is that? That is nonsense. That's old. Non-stoic, which I want stoic. Clutch. Coolant pump. That's fine. Do I have alternator on here? Alternator is all set. So this sets me ahead, especially this single engine. So that's beautiful. That gets me moving here. It's always good to get moving. So let's do composites first. Let's do seat and engine. I'm not going to control it by the seat. It'll be panel, but we'll start with the seat. Logic here. Let me do this really quick. How much space do I have here? Okay, so see, micros can go all the way in on the bottom here, so that's fine. I have plenty of space for microcontrollers. The top or the wing, I don't have much space, but the bottom I do. So let's just start hooking. Battery, alternator. Let's put a battery in here. Sooner I can get this rocking and rolling, we'll do small battery, 10 mass. So 10 mass is equivalent to 3... is equivalent to 1 weight block. So let's put that there. I'm actually going to turn it just so that it's more centralized. Okay, that's good. Also in the nose, I can put microcontrols on the floor and in the nose. That will actually help with weight. Logic, let's go battery there. Let's go. If you think about my train, right? My train uses an absolute insane amount of electricity. It uses 1 medium battery for the whole train. As long as you're recharging your battery at the same rate you're discharging or greater than the rate you're discharging, you can use a small battery for the biggest of contraptions. You know, I could use Triton. I could use one small battery, but it's not realistic, so I don't do it. Alternator, brakes. Good brakes are incorporated as well. Nice. Coolant pump is where are we at here? Where is coolant pump? Or it's the clutch on the fluid pump is what it is. Brakes, coolant pump, clutch goes there. Fuel manifold there. Air manifold is there. Starter. What do you? RPS. All right. And let me just look in here. I want to know what key starts what. I need to do exhaust before I can actually get going. That's going to be seat 6 is start. So I need to see. I have seat 6 set to something. I need to change that. What is that? I don't know what that's all about. Okay, seat 6. 4 is what? 4, okay, 4 is throttle. What's 4? 4 is up-down arrow. Yeah, 4 is the up-down arrows on the keyboard. Is going to be my throttle. I'm just looking at stuff. Brakes is going to be tap 31. Tap spacebar does brakes. That's good. I'm just seeing how I have to set up my seat. All right. So my seat needs. Let me just start setting that up. So we need up, down, reset. 10% is fine. I want trigger. I want it to be push, not toggle. That's brakes. 6 is going to be my starter. What do I have 6 set to? I think I have 6 set to something. 6 goes to what? The gyro. What is 5 set to? 5 is nothing. So 5 is now the gyro. 6 is going to be my starter. And I'll show you why. One of the reasons why I'm using this gyro. What's that? Start. Okay. All right, so I think we're good. Let's try maybe to get this in the air, see if we're hooked. I need to do electricity, so these two here need to go to the hot bus, which means right there. I'm trying to set this up so that what is this crap here? Okay, so that's throttle. I need prop. This will be prop. Prop will be here. What is this one? Get rid of that. Okay. Let's see, that's hooked to prop, I assume. That's hooked to prop. Okay. So what I have is one of the things you have to worry about. So let's talk a little bit of aeronautics. So for aerospace engineering here, ideally you want your somebody asked this about the cateated, how I get it so that the front prop doesn't tip the cateated. This is your center of mass. Okay, that's where your mass is. If you think about it, let's say you have a file cabinet, right? A file cabinet is actually very easy if you push it from the bottom because gravity is pushing all the way down. Center of mass is very low. So if you were to sit down on your knees and push on the bottom of a file cabinet, it's very easy to move. If you push the top of a file cabinet, it tries to tip over, right? Because you're pushing above the center of gravity. So if I put the prop right here in the front and it was right in line with that, it's going to pull very easily. It's going to have no tipping. It's not going to tip the craft. Now, if you look at this, my center of thrust is right here, right at the prop. It's above and behind the center of gravity. So what it's going to do is it's going to push. It's acting as though it's pushing from right here. So what it's going to do is try to tip the nose down. So the way I account for that is I'm actually using the gyro, sending a gyro signal from the rudder here, and then I just put a function of, let me actually show you, about twice. So it's actually doubling the pitch force that the tail is doing, and that's causing the pitch on the prop to actually fix that issue. So we're fixing the torque issue of this trying to push the nose down with the prop pulling the nose back up. So it's counteracting that, and I can change this value, make it more or less depending on what I need. So that's what that's doing. Let's continue with electricity. I want to get this running. All right, that's good. This is my speedo. I have flaps. I think I deleted my flaps. That throttle was for flaps. I was like, I don't know what that is. I'll just delete it instead of looking. So that was dopey on my part. And so what I'm trying to do is I'm trying to segregate the systems now so that when I end up putting in a breaker, it's done for me. This doesn't need power. I'm not switching gears. These don't need power. I'm not switching gears. Alternator needs to go to the battery. These are all control surfaces, so they can just mate up with control surfaces. This is hot. No, this is not hot bus. That can go to the non-hot bus. This can go to the non-hot bus. So you'll see how I set up my systems later. But this, I want a 9:1 gear ratio. So that's Okay, people are still making mistakes with this. You multiply your fractions. So these are fractions. It's a fraction. In this case, it's going to be a 1 over 3, right? So 1 rotation of the engine, 3 rotations of the prop. So 1 over 3 times 1 over 3. 1 times 1 is 1. 3 times 3 is 9. That's a 1 to 9 gear ratio. That's 1 rotation of the engine gives you 9 rotations of the prop. Okay? If this was a 5-2, it would be 1 times 2 is 2. 3 times 5 is 15. 2 over 15 is 7.5 to 1 gear ratio. Okay, so that's how you do gearing. So you multiply the fractions. You don't add the fractions. So just keep that in mind. All right, back to electricity. So those are fine. We're not switching gears because why would we? That's nonsense. We're good here. The blower I'm going to keep to a 1-to-1 now. I'm going to actually put a throttle back in for my flaps. That will be my flap control. Oh, please. Just behave yourself. Okay, good. There. This will go electricity there. And then, so it might do flaperons where these ailerons actually have some flap. But right now, those are my inboard flaps. This is going to help me get off the water. Let's get rid of infinite electricity. Bingo. Let's try to fly this John. This is going to be the first time with an actual engine. I tested it with electric engines before. Okay, so let's start with 6. Oh, no exhaust. Okay, I have no exhaust. That will do it. Make it so beautiful. So I added right here. I should be able to put some exhaust in there. What I think I'm going to do is asymmetrical exhaust that exhausts behind the prop. You'll see what I mean in a second. Okay, I don't want that. I don't want that. Okay, and then I want to do yeah, that's gonna have plenty of space. I'm starting to try to decorate, and I don't want to decorate yet. I just want to get it running here. Okay, so that will exhaust like that. I wanted to do some beefing ass exhaust, but I'm not going to bother at the moment with that beefing ass exhaust. And I'll retool the exhaust. Like I said, I just want this up and running at the moment, and so that's going to be easier for me to get going here. So we have exhaust now. No wonder it wouldn't start. And we should have fuel. We should be good. Famous last word, should I know? Beautiful, we're up and running. Okay, so gear. What is gear? 5? Gear's 5. Gear is up now. Okay. That's good. Up, down is my throttle. Okay, so I'm throttled up. Alright, the prop pitch is 0, so I need to start gently increasing prop pitch, which is 1. I want to turn on my oh. Okay, I already found a problem. Is up, down. Should be sticky, not reset. Throttle. And it is a throttle because you're using a diesel engine. Your actual throttle. It's actually probably fuel injected, so you're actually probably not throttling, but it's just semantics is what I'm going in. Ignore me, it's semantics. Okay, so that's good. Prop is there. Just make sure 1 and 2 are still prop. Labeling things is helpful. Yep, okay. It's backwards because prop is backwards, that's why. Prop plus, and then this will be prop minus. And I'll change that later. It's currently a throttle. I might leave it as a throttle. Kind of like having the throttles in this kind of oldie build. Okay. Alright, what did I... Sorry, again. I need to change the gyro is currently 5. 5 is my gear as well. I want to change this to 4. All right, 4 is gyro now. You know, we could have left the gear up and then used the gyro, but if I put the gear down, we can't use the gyro. So, okay, and this will all be put on panels as is my usual way. So, okay, let's get going here. Turn on the gyro with 4. I'm going to increase my throttle. We'll go max throttle. Okay, that's up, and now I want to start adding prop pitch. Let's put the gear up. Okay, we're going along. Steer a little bit here. Now start pitching up, manually pitching up here. All right, we're gaining speed. All right, I need to decrease my prop pitch here until I gain speed again. Oh, crap. It actually helped me get out of the air. Help me get in the air. So I can easily fix that with using some fins to help hydroplane. I was stuck in the water too much. All right, let's look at our speeds. That's beautiful. All right, I'll do the conversion. Let me actually turn down sounds. Environmental sounds can go down a little. Let's do a quick conversion here. Meters per second to knots. It's about 2.28, I believe. No, 1.94. How did I forget that one? That one I use constantly. 75, so 145. So we are currently faster than the did. Let's see, 100% thrust. We are. Start adding some prop. So the reason why adding prop slows you down is you're doing more work. And so that means you need, if you want to go faster with more prop, you actually want to make it so that as you add more prop, you get more fuel efficiency. But if you want more power and you want to go full prop to get more power, what you can do is you can increase the size of your motor. So what I'm going to do is often around 30% prop is where you get your best speed, because it's a balancing act. You want to balance between how much load you're putting on your engine, which slows down your engine, decreasing RPS, that increases efficiency, but you're also decreasing speed. So this is a big motor. I should be able to squeeze quite a bit more power out of this. So I'm looking at, where are we at? I'm thinking about 0.29, 0.28 is going to be my best speed. No, less than that. 0.26 I think is my best speed. And so this is how you figure it out. You just move back and forth, you check your speed. So 0.26, you can hear the engine speed up or slow down. Let's go to actually a little bit more. You can hear the engine. Yeah, see, we're losing now, so about 0.26 is right where my best speed is. All right, so that's going to give us 78 meters per second. That's 151 knots. So that's about 50 knots slower than I want, but that's not a big deal. I can actually fix that. It's flying really well. Let me take the gyro off. I want to see how it flies with. Now the gyro is always on, but the hover mode is off. So let's shut that off. I've flown this before. I need to, this will tell me if I need to increase certain sensitivities, but okay, I have my hands off the controls right now. It's flying. It's very stable. What this is called is inherent stability. Inherent stability in an airplane is when you let go of the controls and it inherently wants to be stable. Now, this is actually neat. Let me, my degree is in aeronautical science, so I kind of geek out on this stuff. So let's kind of talk about some of the inherent stabilities of an airplane. So we don't get this in game. This doesn't actually happen in game, but watch this. So I let go of the controls. Now, in real life, when you're descending, well, you're going to gain airspeed. And as you gain airspeed, you gain airflow over the wing. The more airflow over the wing, the more lift. So what it will do is it will actually do this oscillation. So I used to teach my students this in flight instructing. They would get so panicked if they, they would panic during a maneuver, like a stall. And they'd panic and I'd say, let go of the controls. And they'd look at you like you had two heads and go, let go of the controls. And the plane would start to dive, right? Well, what happens? It gains airspeed, it gains lift, the nose starts to come up. what happens next? Well, now you're climbing, right? You're losing airspeed, therefore losing lift, and the nose drops. And the plane will literally go into this oscillation, and you can have your hands off the controls, and the plane naturally wants to fix itself. So there are other situations like, can I do a spin in this? And no, probably not realistically. I'm trying to spin it, but I can't get a good spin out of this. All right, so I'm loving this thing, man. It's chonky. It's kind of has hips on it. It flies beautifully. You know, the auto hover's off. A little slow for what I would like, but I'm gonna speed it up. I'm using the default floats. I'm digging those. They don't look bad. Yeah. I could kind of put the center strut and then have 2 window panels. I might do that. I might not. I don't know yet. I'm digging the visibility is great. I can see the wings. That's always fun. I can see the wheels. That's fun. Good visibility here. Let me try doing a landing here. So I'm actually going to do the landing with throttle. And so what's our approach speed there? We're gonna have to come in fast just because of some of the way the game works, but coming a little fast. Actually wasn't that bad. That actually was, we're actually able to get pretty slow. And the reason it's doing this is I'm pushing with the prop, and if I press 4 for the gyro, you can see if I push the prop is actually trying to pull me up, so it keeps my nose out of the water. So I actually probably want to increase that a little bit more, but look at that, man. That's working really well. And so the goal here is to be able to lift this up and put it on top of Triton on the helipad. And I'm out and go do a rescue. Safe. The prop's not a huge deal of me running into the prop. So I might be able to get more speed. I'll lose some efficiency out of this if I actually reduce the gear ratio on that prop. It makes it for a second there, it wasn't making sense to me. The Hummingbird easily does over 200 knots. I think I get 230. And that's two, what are those, 6 cylinders? Let me save it. I want to look at the Hummingbird really quick. The Hummingbird is a fast Johnny. Hummingbird goes 230 knots max speed. Let me see what these engines are. 1, 2. Okay, that's why. It has 16 cylinders total. They're 2.8s. Are they 2.8s? I think they're 2.8s. Yeah, they're 2.8s. So that is 16 cylinders total. So this has fewer cylinders. This has 10 cylinders. So that makes sense. But we should be able to get the speed up. And so what I'm going to do here is the first thing, let's do a little speed testing here. So currently, let's reduce the load on this. We'll do one thing at a time. Let's do our fractions again. So right now we're at a 9 to 1. That's a 7.5 to 1. Okay, so let's see if we can do that. That's going to put less load on the engine. Let's do this. I know I said don't do 2 things at once, but this shouldn't matter. What am I capping this at? 20 RPS. So that's not bad. Okay. So what we did is I'm reducing the load on the engine. All right, so by reducing the load in the engine, I should be able to get more prop pitch. This may or may not speed me up. This is all testing. So we're going to turn the gyro on. I'm going to turn the engine on. I'm going to put my gear up. I'm going to go full throttle. I'm going to start to gently increase my prop. All right, now what I'm going to do is I'm going to I'll add some small fins in the tail to lift up. See, I added too much prop. I need to go to, okay, let me stop us here. Okay. So, I want to go to my max speed prop setting. I need to do this like I'm flying a real airplane is what I need to do. So I want 26 is going to be my best speed on my prop. Gives me the greatest speed without tanking engine performance. So we want that as my starting value here. This is going to give me the best chance to take off. I don't know why the engine's struggling now. What's it doing? I don't know what it's doing. Huh. Let me see if I can, let me yank this back, see what's up. Something's misbehaving. Could be PID settings on the engine, I don't know. Let me get it set up anyway. Let's go to 26. And we'll start trying. I'll do it in third person just so I can see if it does anything strange. 5. I was choking the engine somehow. I don't know why. So essentially what I need is I need to bring that tail up. I need to actually get the whole vessel out of the water a little bit for to hydroplane. So what I'm going to do is this. Let me pull it back. Let's do this now. Let's address this now. Yeah, let's address this now. So all I need is, so in real life, you know, you'll get up on plane on a boat. That will be when you actually get so that you're kind of you're hydrofoiling essentially. So we want to hydrofoil in this, and so I'm going to set that up now to do that essentially. And so how do I want to do this? So I'm trying to think, do I make this visible or not? Or do I care if it's visible? I really probably don't care if this is visible. Yeah, I think we have a little bit of headspace on the nose. So what I'm going to do here is go like this. Try to make it look a little good like that. Okay, and then what I want to do is I want to do some fins. These small fins here to keep them nice and compact. And symmetry, please. Thank you. All right, so those are going to want them this way, I think. So that's going to lift the nose, and I want to lift the tail as well. I think I'm overdoing this here. Yeah, let me not, I don't want to overdo this. I want to do it right here, I think. Let's just do it here. And let's do it here. And let's put the fins in. Like that there, and then these should be going up there as well. And then what I want to do is I want to do a central let me just hook this directly to my pitch control. Yeah, let me try this. I was going to go a little bit more complicated where it only does this in the water, but I think instead of doing that, I think what I'll do is, yeah, I think what I'll do is just set this up pretty simply here and see if this works. So essentially what I wanted this to do is help me get the boat out of the water. The water is sticky like glue, and so you really have to do this IRL in seaplanes. You have to get them unstuck from the water. And so the water kind of wants to hold you. And so let's set this to 26% prop, which should be our best speed probably still, or close to it. Oh, I haven't been putting my flaps down either. How about some flaps? Flaps will help too. Flaps are going to give me more lift right in my center. Again, I'm testing more than one thing at once, but I can go back and fix it. So I need to change the p-value on the engine there. See how easily we come out of the water? This is helping me unstick it. So let's see if I need those now. Remember, I just added those. I just forgot I had flaps, man. I might not be able to need to do this if the flaps because I remembered I didn't need this before, but I did add some mass. So let's test this without and see if I can't get the get that. Let's go ahead and let's yank the P. You know what we'll do? Let's not yank the P value. Let's do my up-down arrow, which is here. Let's change that to 5%. I might just be throttling it too fast. Flaps are good. Let's try that. I'm going to take off with flaps and see if that unsticks me. So flaps, 4 gyro, 5 gear, 6 engine starter. Let's set my throttle to 0.26. Okay, and let's go. I think we're good now. See it much slower? Yeah, it's not flooding the engine when I'm doing that. So I might need something to unstick me. You can see I'm sticking here. Let me start adding some more prop in. Need reduce prop. Trying to get my best speed here. Okay. So this is an issue with that. Let me... See, I think if I put those fins in a closed volume, it's not going to do it. Let's try this. Yeah, I think we'll just add a little fins on the exterior like this. And we'll go reconnect those. That's just going to help me unstick. The flaps are definitely helping as well, I think, but the flaps will help me get to a slower speed. I've already tested those out before and they worked well. So let's go ahead and let's go to, where's gyro pitch? Gyro pitch, and let's hook these all up. Okay, and then let's go give this a test. I changed the engine stuff, so I want to test that out. I don't want to get too sidetracked to forget what I changed. Flaps are 100%, 4, 5, and 6. Set the prop to about a 0.26. All right, let's go here. So see how we rise out, see how the body of the craft rises out of the water? That's what those fins are doing for me. And so they're allowing me to unstick myself from the water a little bit better. So I need some more speed to get out of the water here. See, I'm trying to get my tail out. There we go. See, once I get unstuck from the water, we're good. So the other thing I was thinking of doing is adding flaperons, which is essentially what, as you add flap, it also bends those ailerons down. So I think I might do that. All right, so now as you can see, we've cut our drag down, so now we're our flaps are up. So we're at point. So we lost some power doing this, which is that was a possibility. I kind of was expecting that might happen. See if I can go more. Actually, we didn't really. By reducing the RPS, it's going to allow me to put in more prop pitch because I'm reducing the load. I think I want to stay at. Let's do this. We're gonna try to. We're gonna do this instead. Okay, so that was fine. That was a good test. Let's go back to 3-to-1 on this one. So that's going to increase my prop more. That's going to give me another 1.5 RPS on the prop itself. If I want more RPS, I can also change blade quantity. I like the 3 at the moment. What I can do now is, so this is my blower essentially. This is my supercharger. I'm gonna be losing engine power, but I'm gonna be blowing more air in it, which is gonna allow me to suck more fuel, which could give me a big boost in power. All right, so I need a little bit more power to help me unstick from the water. So let's go full flaps. Let's go to negative 0.26 was our best speed at this gearing. So there we go. Let's go ahead, 4, 5, and 6. So the blower should be blowing more air in the engine, which allows me to have more fuel. And I should have put an RPS gauge in there. Look at that. Okay, so that by changing the blower, that gave me enough air that we have more than enough fuel. We unstick really quickly. And let's put the flaps up. Look at that. We're already faster here. Not gaining huge amounts of speed, but we have more engine power. With more engine power, we can do more work. With the ability to do more work, we can add more prop. And so that's what a lot of people are kind of confused about, is this allows me to add more prop. So now I've gone up 0.04, and as you can see, we're gaining more speed. But you can hear my engine slowing down. So let's add some more prop. So this here is probably my new best prop setting, about 0.3. Let's go to 0.3 on the dot here. Yeah, so 0.3 prop is probably going to be my best. Let's go a little bit less. So as you can see, because we increased engine power by increasing the air and fuel going into it, we can then increase the amount of work it's doing, i.e. prop pitch. So right there it's 82.9. Let's go down a little bit more. Let's go, we'll do it at 2 decimal places at a time. Okay, good. So we found our best speed. Best speed is going to be 0.3. So this is what's known as a complex aircraft. Complex aircraft has variable pitch propeller, also has retractable gear, and so this is something you have to learn for your commercial license. And so the what you're doing is, like, let me go full prop right now. If I had a Boss huge engine, I could go full prop, but what I really want my full prop for is I want to be able to decrease the RPM on the engine. I want to add extra load to the engine. Now what I'm doing is I'm still going a good speed. Still doing 65. Let's actually read out. So I was doing about 83 meters per second. That's 161 knots. That's pretty good. We're now at 66 about. That's 128 knots. You can hear my engine slowed down. I'm going to be burning a lot less fuel. And so what you want to do is you want to make it so that a higher prop setting gives you better fuel economy. And so by getting better fuel economy, this allows me that, let's say I need to fly to the Arctic, right? And I want to make sure I have enough fuel for the Arctic. What I can do is I can increase my prop. Let's say I'm trying to go to a rescue. I want to get there really quick. I can go to 2.6. If I go below 2.6, I'm really getting no benefit. Or, I'm sorry, below 0.3 now, I really don't get much benefit. I want to increase my prop, because if I want to go slower, I want to actually have more prop in there, and that's going to give me greater fuel efficiency, essentially. So as you can see here, we're still doing a good speed, but you can hear the engine's running a lot slower, and that's giving us greater fuel economy. All right, let's see if I can't take a glamour shot. I don't have a glamour shot for this video yet. Volcano? Can I see the volcano? All right, now I'll do a couple glamour shots here, but this is working really well. This is it's turned into a fun little plane, and it's gonna be nice to be able to land this on the to be able to land it on the ocean next to the next to Triton. And that will allow me to and land it on the ocean next to Triton. Then I'll be able to pick it up out of the water. So now, when we land, we want to go to our max speed. Our best speed was going to be 0.3. All right. And what I'm going to do here is I'm going to land it on the land. We're going to try it here. We landed it on the water already. Let's go full flaps. Let's go ahead, gear down. All right. And geometry still looks good with the new hips. Let's go ahead. I'm going to take off the gyro because I want to hand fly it. All right. And what I'm going to use now is I don't control the prop anymore. The prop is set. Now, when you have a non-complex propeller plane, it has a fixed pitch prop, which you could do in game, but not really. You'd have to hold the brakes the whole time. But you have a fixed pitch prop. The pitch is always the same, and you change RPS. In a complex, you set the prop where you want it, then you change the throttle. So essentially, you're able to be a fixed pitch, but choose your pitch. Now I'm going to use throttle. So I'm using my down arrow to throttle to control my speed. Flaps are full flaps. I'm coming in for landing. We have to remember there's a tail dragger, so I want a little bit of a nose up attitude. We're doing 66. See if I can get down to at least 45 or 50 meters per second would be really nice. I think I can get pretty slow because the flaps are quite big. Oh, this is gorgeous. This is a beautiful speed. This is really coming in nicely. I'm a little fast too. You see I'm floating. People dog on the Aerodynamics and Stormworks. I think people need to dog their own flying ability, and I kind of say that jokingly. You know, I was a commercial airline pilot. I understand that most people don't have the skill set to fly well, and that the game needs to be approachable to novices. Absolutely, and I agree with that. I just find it funny when people they dog the flight model of the game. And, you know, that's what my degree's in, and I come in and it feels like a real airplane to me. You know, it certainly does things like it doesn't glide, absolutely. But, you know, you just saw me come in, and it felt like I was landing a real airplane, like I've done literally thousands of times. And, you know, it felt right. You saw I was on center line, came in nicely. I knew I was fast. You know how I knew I was fast? Experience. I could feel that I was fast. You know, I could feel everything. The tail wheel's working beautifully. Look at that tail wheel. That's beautiful. I'm really falling in love with this build now. It's coming along. It's going to be a really good tool in our toolbox. I'm enjoying this a lot. Look at that thing. This sucker is boss, man. This sucker is boss. It really is good. I love it. I'm really loving this little bird. And seagull, I think. You know, I was kind of going to save it for something that was a little bit maybe more dangly, but maybe I'll find a name that's a little bit more fitting, but we'll see. I'm loving this build. This is really coming along nicely here. And so the goal is what I'll do is I'll put either a rope connector or a hard point connector on the top, and then I will use Triton to use the crane and lift it up, and I will put those two locking lugs that I have on the did underneath, and that way I can lock this to the pad. But this is working super well, man. Got a little time here. Let's fly back. Let's do a takeoff here. So we want flaps 100%. We want our thrust set to 30. Let's go ahead and taxi out. This is awesome. So I think I'm going to add flaperons. So the way a flaperon works is, so let me articulate my ailerons. So you see how one goes up, one goes down. So when this one goes up, that's a loss of lift on the left. That's a gain of lift on the right. So that right wing comes up, left wing goes down. That causes you to bank and turn. All right. So what a flaperon will do is the flaps will go down like they are there, and then I'll still be able to move them, but they still leave some of that lift in there. So I'll show you when I do it. All right, let's get out of here. Why am I not increasing my throttle? Oh, here we are. It's just being slow. The p-value needs work. Oh, I'm going to need... Oh, look at that. Speaking of aerodynamics, you know, the acceleration is too much, but that's mostly that we have too much thrust in Stormworks. Not even too much thrust, is the vehicles aren't very heavy, so they don't have... You don't need much thrust to get them moving. Let's put it that way. That's more accurate. Beautiful. And like that, you know, the flaps are giving me drag, which they should. I forget what that is. Parasite drag, maybe? I can't recall. Put the gear up. So, like, in real life, the CB, the wheels actually go up beyond 90 degrees. and that's to keep them out of the water. But yeah, this is working really well, man. I'm really happy with this and enjoying it. It's a fun little plane. Like I don't gyro off, gyros off. Yeah, gyros off. I took off with the gyro off, no problem. Probably, yeah. I don't even know if I need the gyro on for taking off in the water. Let's head back to Spy Cakes, and we will call it there, I think. Just kind of a nice little leisurely flight over there. Like, I'm taking my hands off the controls. If you build something right, it will have inherent stability. Now, if you look, I let go and the nose drops down. That's fine. That actually happens in real life. You need to trim, and that's when you hold your Alt key and you put in some trim. So, like, that trim is all I need. Okay, that's it. And you actually trim constantly in real airplanes. You're trimming all the time. And so the gyro kind of does that for you. It's like almost like auto trim. But, you know, like I'm going to hand fly this without using the gyro the rest of the way back. I might make custom pontoons. I haven't decided yet. These don't look bad. They're not perfect by any stretch of the imagination. They're a little bit square for me, but they're functional and they work well, and that's kind of the most important thing to me. Get the plane working right. Last thing I'll do before we end this video is I will I'll put in the flaperons, and we'll do a quick test with the flaperons. Make sure everything works. Make sure I have enough authority, because what I'm actually losing is I'm losing some of my ability to roll. But as you see, I'm not using my full roll capabilities, so I can actually steal some for flaperons. All right, we'll start to throttle down. We leave the gear up on this one. Let's get down to, I want to see if I can get to 45, because if we plop out of the air, we're gonna we'll bob in the water. It's not a big deal, so I'm gonna actually test how slow I can get. There is 46 knots. I don't have any flaps in. Okay, there's 46 knots. Gorgeous. I can come in probably at 40 knots, I would say, and be fine. And see those little fins there? Those are allowing me to get out. What I think I'm going to do is add a fluid meter, and then those will be automated with the... See, I lose all steering in the water, which is fine. What I'll do is I'll fix that right now. Okay, let's do this. Let's get rid of that. Let's add a fin. I need to look at my rudder up top. Hollow on the left side. Hollow on the left side there. Okay, and then what I'll do is I'll hook this up to whatever's controlling my rudder, which I think is direct control, left, right. Usually don't need a gyro for the rudder. And then I need to add in something here to seal this back up. Okay, that's done. So now that will actually allow me to steer in the water now. Good. Electricity needs to be connected. Okay, right there is good. Let's add these two systems right quick. So let's do it at do it in the tail, because the tail stays in the water the longest. Let's get a meter. Okay, so essentially what this will do is read if we're in the water or not. And then so if we're in the water, it will cause these to go full deflection. Let's do that. Okay. So let's do this. Oh, get out of there. Gets frustrating when I click on a block that, or have a block that I don't want to. Let's do let's do foils. Foils. Okay. We want to take in a number from the fluid meter. All right, and we want to output a value to the fins. Okay, let's go in here. So let's say essentially if this is greater than 0, numerical switch box. That will activate the foils. So essentially, if this is greater than 0, we want to switch on. So that will give us a constant number of 1. So that will give us full foils. As soon as we exit the water and that tail reads a 0 for that for how much water's in there, because we'll be in the air, there'll be no water. It will automatically shut the switch off, and that will give us a 0 on the foils, so they'll just sit and they'll be passive. So that system should work. Let's put that in there. Logic here, we want this to go to the meter here, so that's fluid level. We don't want capacity, we want level. And then we want foils, we want these 2 fronts. And we want these 2 tail ones there. And that should fix that. Then I want to do flaperons, so let's do another one for flaperons here. I might integrate it into a big panel, but when you have a plane like this, it's often nice to have some smaller panels because they're easier to hide. If you do big panels, you get in a situation where you're going to struggle to hide them all. Having a ton of little panels on a small build makes it really nice and easy to be able to hide them all. So that's why I'm doing this. Let's go properties. This is going to be flaperons. Flaperons. Okay, so that's a compound word of flaps and ailerons. So there's going to be number input from the flap handle. Flap handle. And then this is going to be a number output to the, I need, I'm going to need 2. I need, let's do output to port, aileron. This is going to be starboard aileron. Starboard aileron, output of a number. Okay, and so what I want to do here is, let's see, take that. I want, all that's gone. All right, so what I want to do is I want to take my reading from the flap handle. All right. Yep, this should work. And okay, so that I'm trying to think if I need to clamp that or not. I probably don't need to. I also need to get another input from the roll, number input roll. Okay, so this is going to read my roll. It's going to add it to all right, add it to, so we'll take the flap handle and we'll add it to the, which one's negative? Yeah, so I need to add a negative value. It's flipped, so I don't need 2. I need 1. Let me do, so I should be able to do it like this. It's already inverted. I need to invert it in here. So what I want to do is I want to, I'm trying to think. I do need to add it that way. Okay, yeah, I need to add, I need to have 2 now. That's fine. I could flip the flap as well, or flip the aileron as well. Let's do number output port, number output starboard. Okay, that's an output, that's a number, output. Okay, good. So let's fix this up. So I want to read my reading from my flap handle, and I want to add that to whatever my roll is. That's going to be port. And then here I want to go starboard aileron, and I want to do a function of negative x. That will invert the roll signal, and that will invert the roll signal on my starboard aileron. So that should work out nicely, I think. Yep, that should work out nicely there. And let's do some pedantic nonsense here of setting these up. Okay, That should work. Update. And then what I need to do is I need to come back here, and this aileron is now inverted. You see how that has solid up top, and this has hollow. I inverted it in the microcontroller, so this can now be hollow, 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 hollow. So I needed to invert it somewhere, and so I just chose to do it there. Let's go ahead. Oh, did I just cut something? No, I didn't. Okay, good. Let's go ahead and hook up the starboard aileron. Let's go ahead and hook up the port aileron. Flap handle is right here. And I might have to clamp that. That's still a potential. And roll. All right, let's test it really quick. And so we did a couple things. Remember, we see these are sticking all the way up now. See that's sticking all the way up. That's because we're in the water. That's what we want. And then we'll go in and we'll test my ailerons if they turn in the correct direction. Why are you not jumping, dude? Jump, jump, you dope. What is he doing? He's being dopey as the day is long, I'm telling you. All right, let's go in here. Let's add full flap. Now, you should notice all the flaps go down. Now, I should be able to roll left. See, that one on the right is going to stay all the way down. This one is coming up some. So this one here is going to keep lots of lift. This one's going to lose some lift, causing this wing to dip, causing this wing to rise relatively to that one and rolls. All right, let's start it up here. I might need to clamp it, might not. Set this to 0.3, which is our new best speed. Okay, which I'm actually going to probably clamp that out. We want 5. We want 4 for gyro. We want 6 for start. All right, let's go. Look at that. All right, so I'm a little bit wallowy on my roll. I don't have as much roll control as I'd like. So I probably want to clamp those flaps out just a little bit. Like right now I'm trying to turn left. This is as fast as I can turn left because the way the flaps are set up. So now as soon as I get rid of flaps, you notice I get my full control back. So I need to probably clamp it maybe to 50%, I'd say. Let me actually test it without the gyro on too. Full flaps. Yeah, see, like I don't have enough control because I lose too much of my control of the flaps, which is nice. If we look at those little fins here before I crash, see how they're flat now? We're not in the water, so those will automatically cause us to hydroplane in the water, which is what we want. All right, gorgeous. So this is working well. Let's just quickly throw a clamp in there, and then we're all set. So we want to limit the our flaperons so that we only get 50% of the flap, essentially. So what I'll do here is I'm going to just clamp this out. And then this will go like that. All right, good. So now that's set up. This is clamping 0 to 0.5. So now we can only use, I'm going to do 0.5. 0.7 sounds like too much. We're taking off fine. I don't want to lose control. If we had issues and we couldn't take off and we needed more flap, I would say, yeah, let's limit to 0.75 and test it, but we don't use it. So see, the inboard flaps are giving us lots of flap. These are going to 50%. Now you see I get more roll authority. I can actually move my control surfaces more. Those fins are still sticking up, so let's go 4, 5, 6. And I probably actually don't, I could probably take off without the gyro on now because those fins underneath me, the hydrofoils, are no longer, oh, I need to add some prop here. I'm going to do nothing. Let me see how I'm steering. So see how I have a little bit of steering authority in the water now where I didn't? That's because of that little fin. Because until I get up to speed, that tail fin's not going to do anything. In real life, see, I need to limit my rudder because see how I'm hitting my other rudder? I don't want to glitch it. And, you know, in real life, that prop would be blowing over the tail and you'd have more than enough tail effectiveness, but in this we don't. So see how this keeps us nice and high in the water? We're hydrofoiling. Let's go. Full throttle. right out of the water. Gorgeous. This is really working well. See how I can roll? I can still roll nicely. Let's take gyro off. See, I can roll really nicely because I limited the amount of flap in there. So we have lots of good flap, lots of good wing area. It changes the camber of your wing, giving you more lift. So that's really working well. So let's end it there. You know, went a little long here with just trying to do that last little test, but this thing is flying beautifully. This is really good. I'm going to put go ahead and put a RPS gauge in there, and we'll see how much fuel we're burning. I think this thing's going to be super fuel efficient, and that's going to be really awesome. So I will see you guys in the next one. I hope you enjoyed. If you liked the video, give it a like, please. And if you enjoy my content and you're not already subscribed, please consider giving me a subscribe. And I'll talk to you in the next one. Bye.